These two in the middle should match up. The ones that match up, I can pull out. What's left over goes together. So that's what it factors into. X minus 3 and then 2x plus 1. And you set each one of those equal to 0. You get x equals 3 and x equals negative 1/2. Okay, now again, remember it goes negative infinity. The lowest one, pick up with that lowest one. The next one, pick up with that one. Keep going until you get to infinity. Amaria, what's this one going to be? Very good. Look at us writing domain. I'm pretty sure at the very beginning you thought, no way, I hate domain. It's not so bad. No. Okay, good. All right. Now let's go to square root. For the square root, we had a way that we set it up on the last one. How was that? Yes. What was under the square root, we set greater than or equal to 0. That is called, by the way, that's called the radicand. The number that's under the square root. Because I'm going to use that word and I just wanted you to know what it was. So the domain of a square root function will be the interval of values that make the radicand greater than or equal to 0. Okay, so again, we'll do that first one together. It would be x plus 3 is greater than or equal to 0. Subtract 3 from both sides. X is greater than or equal to negative 3. So that means negative 3 is the smallest because it's got to be greater than it. And it includes it because it's greater than or equal to, so that's why it's a bracket, to infinity. Can't include infinity. You try the next two. by the way, you'll see up here, some students writing what day and then questions that they had. My calculus students do that because they had me for pre-cal last year. So feel free if you want to do it like that. That way you don't have to say anything and I can just look up and see it at the beginning of class. But I will also ask for it. So if you ever have a question, you just want to write it up here, feel free. Just write it under pre-cal and I'll know. We'll be sure and go over that. For future reference, even if it's an old one, I don't care. Okay, so Tyler, how are we going to figure this out? What do we do?
Number 2?
Yes, sir. Sorry.
Okay. So I put negative 2x plus 4 is greater than
okay.
equal to 0.
Okay. And then what? Sorry.
I subtracted 4 from both sides.
All right.
And I did both sides by negative 2.
Good.
And the sign flip.
Good. So x is less than or equal to positive 2. That's absolutely right. If you guys left it as 4 minus 2x is greater than or equal to 0, you should get the same answer. So it does not matter, it works the same. So then, Hazella, how would I write that?
Negative infinity to 2, and it includes 2.
Very good. Notice it's everything that's less than that. So that's how I knew to start with negative infinity. If it was everything greater than that, then I would start with that number. Make sense? Good. All right, Justin, how would I do the next one?
Say 3x plus 1 greater than or equal to 0.
Very good. Go ahead.
Then subtract 1.
Good.
Then divide 3.
Good.
It would be a negative 1.
It would be. You are absolutely right. Thank you, sir. So then it's x is greater than or equal to negative 1/3. And Becca, how would I write that as a domain?
Bracket, negative 1/3, and then comma infinity.
Very good. Yes, ma'am.
Doesn't the sign flip?
Good question. The signs flip only if you divide or multiply by a negative. So since I'm dividing here, I'm dividing by a positive 3, I don't flip it. And I'm subtracting 1, but I can subtract. I just can't divide or multiply by a negative without flipping it. Excellent question. Any other questions? Okay, moving on to the last part. Cubed root functions. It seems like, most of them, they've been from negative infinity to infinity. I don't have a problem with cubed root functions. Unless there's something weird under a cubed root function. That's the only time I'd have a problem. So the domain of a cubed root function is negative infinity to infinity, unless the radicand, which just means whatever under the radical, which in this is a cube root, happens to be rational. In which case, any value of x that makes the denominator equal to 0 must be excluded. only in weird circumstances. Which we can look at pretty easily and pick out which one's going to be my weird one. H of x, yep, the third one, number 3, because it has a fraction under that cube root. So the first two, we don't have to do anything for. Because it's a cubed root and not a square root, we can just say, oops, it's negative infinity to infinity. It's only the square root one that gives us problem. Now, Jenna, what's going to give us a problem on h of x?
It's a fraction.
Yes. So what part of the fraction gives us a problem?
The denominator.
The denominator. So I said 2x plus 1 equal to 0, and that's where it's going to give us the problem, just like when we were doing rational functions. So I subtract the 1 and divide by the 2. So I only have 1 there that I have to worry about. Usually there's been 2. So Mario, what's that going to be? Negative infinity.
Oh.
You're
Yeah,
fine.
-1/2.
Good. Union.
-1/2.
Good. Yes. Now, if it was that square root thing, then that's what you were thinking of, which makes sense. Excellent. Okay. Well, now you are good to go with day 7's homework. So usually we pick up, but we're almost done. So tomorrow we'll start on the next thing, but go ahead and start on day 7's homework so that you can ask questions about it. Hopefully I'll remember to post the answers for day 7 as well. Yes, ma'am. Oh, totally forgot. Thank you.